Okay, in this problem we have this kind of ridiculous coordinate plane, which is measured out in kilometers. And we've got this character Robin, who is traveling across the coordinate plane according to these parametric equations, which time is measured in hours here. And so at any given point, her position in kilometers, I guess, from the origin, is given by these two equations. So we could calculate these. She starts out at -2, 1, and then she's increasing every hour 3 units in the x direction, 4 in the y direction. So it's going to be, 3 units would be +1, and then 4. Let's add another one here, 7, and she's increasing 4 units in the y direction. So that's going to be 5, 9, 13, so on. And we can plot these points over here. We'd have, so it's over 3 up 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. So here is Robin's path. And this is for Robin. This is time equals 1, time equals 0, time equals 2, and time equals 3. So those are all Robin's positions. Now, we've got this other character, Casey, who is lagging behind by, say, 10 kilometers. So same speed, but 10 kilometers back. So it basically means that Robin is here at time equals 0, time equals 2, time equals 1, time equals 2, and by the time Robin gets here, Casey's 10 kilometers back, right? So here is Casey at time equals 2, right? So at time equals 2, here's Robin, here's Casey, 10 kilometers back. And we know that's 10, by the way, because this is that 3, 4, 5 triangle. So Robin is traveling 5 kilometers per hour. Right? We've done all that before. So here is Casey at time equals 3, and Casey at time equals 4, and Casey at time equals 5. Okay? So at any given time, here's Casey at time equals 0, or time equals 2, and Robin at time equals 2. At 3, here's Robin, here's Casey, 10 kilometers back. At 4, and now Robin's kind of off of our graph here, but there's Casey. So we can put Casey's times over here. Casey. And let's see, at time equals 2, Casey is where Robin is at time equals 0. So here's Robin's time, here's Casey. That's a 2. And then let's see, at time equals, Robin's time equals 1, that's where Casey is at time equals 3. And then 4, and then 5. Okay. So we can see that Casey's at all the same locations that Robin is, but at a different time. So he reaches them 2 hours later. So Robin gets to this point at time equals 0. Casey gets here at time equals 2. At the point 1,5, Robin reaches that at time equals 1, but Casey doesn't get there till time equals 3 hours. All right, and so on. So we're just going to have to write an adjusted equation. And notice all we have to do is take Robin's time and add 2. Robin's time, add 2. Robin's time, add 2. So Casey's equation will be, starts at the same location, plus 3, and instead of just t, it's t plus 2. Right, and then for our y, it's going to be 1 plus 4, and we're just going to add 2. And we can simplify these equations if we wanted to. But we get the gist here. It's the same equation for Casey as it is for Robin, with the exception that we replace t with t plus 2, which accounts for the fact that Casey is 2 hours behind Robin.